Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Data File Handling, Part 6, for the Class 12 students of Computer Science. In this video, we are going to learn binary files. What is a binary file? Reading and writing data from and into binary file, serialization, pickling, unpickling, Python pickle module, pickle.dump method, pickle.load method and practical implementation. So, let's dive in and get started. Let's discuss about binary files. What is a binary file? A binary file is a computer file that holds special codes instead of words or pictures we can understand. These codes are like a secret language only computers know, and they're used to do important computer tasks, like showing images or playing music. Now, look at the first point. A binary file in Python is a type of file used to store non-textual data. This means that a binary file is not designed to hold human-readable text like sentences or paragraphs. Instead, it's intended to store data that doesn't have a natural textual representation, such as images, audio, video, or program code. It contains data in its raw form, represented as sequences of bytes. This means binary files are like data blueprints. They're made up of tiny building blocks called bytes, each representing a number from 0 to 255. These bytes hold important secrets, like pictures, sounds, and computer instructions. Understanding them can be like reading a secret code and might need special tools or knowledge. Third point. Binary files are used to store various types of data, such as images, audio, video, executables, and serialized objects. Most of the files that we see in our computer system are called binary files. For example, document files, image files, video files, audio files, database files, archive files, executable files. Unlike text files, binary files do not use character encoding and store data as is, without transformation. In text files, characters are encoded using a specific character encoding like UTF-8, which allows humans to read and understand the content. Binary files, on the other hand, do not involve encoding characters. They store the actual bytes of data without any attempt to interpret or transform them into human-readable characters. The data in binary files might represent things like color values, sound waveforms, or machine instructions. These bytes might not make sense when viewed as text. Now, come to the next point. Python's built-in open function is used to work with binary files. Binary files are opened in either read mode, RB, for reading or write mode, WB, for writing. Reading from a binary file involves using the read method to retrieve bytes from the file. Writing to a binary file involves using the write method to store bytes in the file. Let's discuss about reading and writing data from or into binary file. To write a structure such as list or dictionary to a binary file and read it subsequently, we need to use the Python module pickle. The module pickle is used for serializing and deserializing any Python object structure. So, what is serialization? Serialization is the process of converting complex data structures into a format that can be easily stored, transmitted, or shared. Serialization is like turning your favorite toy into a picture so you can put it in a box, send it to a friend, and they can use the picture to make the toy look exactly the same again. So, serialization is the process of transforming data or an object in memory, RAM random access memory, to a stream of bytes called byte streams. These byte streams in a binary file can be stored in a disk or in a database or sent through a network. Serialization is commonly used in programming to save the state of objects, lists, dictionaries, and other data structures. Serialization is also called pickling. So, what is meant by pickling? Pickling in Python refers to the process of converting a Python object into a binary representation. It means the process to convert any kind of Python objects such as list, dictionary, etc., which is human-readable form, into byte streams, that is, zeros and ones, machine-readable form is called pickling. It's like putting the object into a jar so you can save it or send it somewhere else. The pickle module in Python is used for pickling. Pickling is used to save complex data structures, like lists, dictionaries, and even custom objects, in a way that they can be stored or transmitted. The resulting pickled file is binary and not human-readable. Why it is called so? The name pickle comes from the concept of pickling in cooking, which refers to the process of preserving food by storing it in a container. In the same way, the Python pickle module preserves and stores objects by converting them into a byte stream. Now, look at this picture. Pickling refers to the process of converting the Python objects or structure to a byte stream, machine-readable, before writing to a binary file. Unpickling is the process of taking a pickled binary file and converting it back into a Python object. That means, we can convert the byte stream, zeros and ones, generated through pickling, back into Python objects by a process called unpickling. It's like opening the jar and getting the object out. The pickle module is also used for unpickling. Unpickling restores the original data structure, including all the values and relationships. This is useful when you want to use or manipulate the saved data in your program again. However, be cautious when unpickling data from untrusted sources, as malicious code could be hidden in pickled objects. In short, pickling and unpickling are ways to store and retrieve complex Python data structures using a binary format. Now, look at this picture. Unpickling refers to a reverse process where the byte stream, zeros and ones, machine-readable, is converted to the original structure, human-readable. We know that the methods provided in Python for writing or reading a file work with string parameters. So, when we want to work on a binary file, conversion of data at the time of reading as well as writing is required. Pickle module can be used to store any kind of object in a binary file as it allows us to store Python objects with their structure. So, for storing data in a binary format, we will use pickle module. The steps to perform read and write operations on a binary file are: Step 1. Import the pickle module using import pickle statement. It provides two main methods, dump and load. Step 2. Open a binary file with the required access mode. For creation of a binary file, we will use pickle.dump method to write the object in file, which is opened in binary access mode. The syntax of dump method is dump of object, file object. Step 3. For reading data from a file, we have to use pickle.load method to read the object from pickled file. The syntax of load method is object equals load of file object. Note that we need to call load method each time dump method is called. Step 4. Once all required operations are done on a binary file, it is to be closed using close method. Python pickle module is used for implementing the binary file structure. Dump and load functions are used for pickling and unpickling the binary files, respectively. Let's see a program to write structure, list in the binary file. Now, look at the main code, main.py. In line 2, the f operation function is defined. This function is responsible for writing a list of numbers to a binary file using the pickle module. In line 3, the pickle module is imported. This module provides a way to serialize and deserialize Python objects, allowing them to be saved to files and read back later. In line 4, a list named list1 containing numbers 10, 20, 30, 40, 50 is created. In line 5, the program opens a binary file named list.dat in write binary mode, WB. This mode allows you to write binary data to the file. In line 6, the pickle.dump function is used to serialize and write the contents of list 1 to the binary file f. This function takes two arguments, the object you want to serialize and the file object to write to. In line 7, a message list added to binary file is printed to indicate that the list has been successfully written to the binary file. In line 8, the file is closed using f.close method to ensure that all data is properly written and resources are released. In line 9, finally, the f operation function is called to execute the operations defined within it. When you run the program, the operations defined within the f operation function are executed. As a result, the list 10, 20, 30, 40, 50 is serialized using the pickle module and written to the binary file list.dat. The message list added to binary file is printed to the console to indicate that the operation was successful. Now look at the right side of the screen. If you were to examine the contents of the list.dat file after running the program, you would find the binary representation of the serialized list. This binary data wouldn't be directly human readable, as it's meant to be interpreted and deserialized using the pickle module in a Python program. Example 2. Python program to write structure, dictionary to the binary file. Now, look at the main code, main.py. In line 2, the pickle module is imported. This module provides a way to serialize and deserialize Python objects, which allows them to be saved to files and read back later. In line 3, a dictionary named dict1 is created. This dictionary contains key-value pairs representing subjects and corresponding scores. In line 4, the program opens a binary file named bin_file.dat in write binary mode, WB. This mode allows you to write binary data to the file. In line 5, the pickle.dump function is used to serialize and write the contents of dict1 to the binary file f. This function takes two arguments, the object you want to serialize, in this case, the dictionary dict1, and the file object to write to. In line 6, a message dictionary added to binary file is printed to indicate that the dictionary has been successfully written to the binary file. In line 7, the file is closed using f.close to ensure that all data is properly written and resources are released. The program essentially writes the dictionary dict1 into a binary file named bin_file.dat using the pickle module for serialization. The data is stored in binary format, which can be used later to deserialize and reconstruct the original dictionary using the pickle.load function. After running the program, you should see the printed message dictionary added to binary file on the console, indicating that the dictionary has been successfully written to the binary file. If you were to examine the contents of the bin_file.dat file after running the program, you wouldn't see the actual dictionary content in a human-readable form. You can check the contents below of the screen. Instead, you would see the serialized binary data that represents the dictionary, which is not much in human-readable form. This binary data is meant to be interpreted and deserialized using the pickle module in a Python program to retrieve the original dictionary. Let's see how to write a Python program to read dictionary items from the binary file. Now, look at the main code, main.py. The given code is a Python program that demonstrates how to read the contents of a Python dictionary from a binary file using the pickle module. Now, look at line 2, import pickle. This line imports the pickle module, which provides a way to serialize and deserialize Python objects, allowing you to save and load complex data structures like dictionaries. In line 3, f equals open of bin_file.dat, rb. This line opens a binary file named bin_file.dat in read binary mode, rb. The RB mode is used because Pickle deals with binary data. The file should contain serialized dictionary data. In line 4, dict1 equals pickle.load of f. This line uses the pickle.load function to deserialize the content of the binary file and load it into the variable dict1. This assumes that the content of the file is a serialized Python dictionary. In line 5, f.close function. After reading the dictionary content, the file is closed using the close method to free up system resources. In line 6, printf dict1. Finally, the code prints the content of the deserialized dictionary, dict1, to the console. This will display the key-value pairs stored in the dictionary. You can see the output displayed in human-readable format. Thanks for watching. Watch the upcoming videos. Data file handling, Part 7. Binary operations, inserting or appending a record in a binary file, reading a record from a binary file, searching a record in a binary file, updating a record in a binary file. You can check the link in the description box given below.